Our next presentation comes from VAST, Jan Heichier and Maria Gutierrez.
Okay. In the last years, most people have talked about how important data is and how data-centric the world becomes, and still there seems to be a bit of a gap in what users expect to get and how infrastructure is built these days. And the idea for this talk was basically to bridge the gap a little bit and show the other perspective for how does an infrastructure look like when you only get file as a user, and how do you solve your AI problems. So we are both from VAST, Maria and I. Maria's one of our technical directors in the field. I'm heading a pre-sales overlay team for AI and HPC. And this is not the VAST product pitch. You already heard how awesome the product is because Roberto delivered that. It's completely neutral what we are explaining here. This has nothing to do with any vendor thing. And still we wanted to take the opportunity to explain a few things that we see in the market being built wrongly, if I may so blunt. Maybe so blunt. I actually wanted to name the talk "The File is Not Enough," but people were not agreeing with my sense of humor, so I didn't get that through. But in general, there is something true about it. We see infrastructure being built today with the knowledge of 20, 30, 40 years of HPC for AI with that knowledge, but it's completely driven in one direction, and it's driven down the path of performance. People agreed in HPC that file is the consumption model for data, and the only thing I care about is capacity and performance. That's it, and this is how we see AI infrastructure being built today. But the idea for this talk is that while most people agree that data becomes more important, it's completely unclear on what that actually means when we talk about that people consume the data differently. So we wanted to illustrate a few things on how a practitioner works with data. And if we build AI-ready infrastructure with an HPC mindset, then we end up with something only delivering file. And we want to show you why that might not be enough to make it easy enough for users to use that from the AI perspective. In that context, we talk about AI users, but we don't mean people that use a chatbot or something. We mean more like practitioners, people that put together AI stacks and that have a project that they want to solve with AI. So it's more on the development side of things without the necessity of training something from scratch maybe, but maybe they do. So this is the perspective. It's not a pitch about a product or anything. It's more about creating some understanding on how does someone from outside the HPC or outside the infrastructure world looks at something that you build. So let's think about an arbitrary project, right? So someone wants to create a medical assistant SLM, a small language model. We all talk about LLMs, but it's maybe good enough to have a small model doing that. And to keep it personal, so this is Dr. Vance. Dr. Vance has that project. It's a medical researcher. And she has a task to basically implement an end-to-end pipeline to diagnose or to sort notes or unstructured health records and search for stuff about rare diseases. It's a highly specific task. It's nothing that I can use ChatGPT for because that's been trained on normal data, let's say, general data. So I have to start a project around that. And that's a small project, right? This is not about 100,000 GPUs. This is not about hundreds of petabytes of data. It's a small project, but it is something that might happen in real life. The example is completely arbitrary. We made it up, right? It's not a real customer, but it's close enough to what we see our customers are doing. So what are the steps of that project then? Well, typically you don't start with training a model. You take a model that exists, a small model, because we want to do we want to have a low resource intense pipeline in the end. So we pick an open source model, and I think we picked Gemma with 4 billion parameters. Nothing exciting, but since this is a generally trained model, we need some data. We need to collect data. And we need to find the specific data that we need because we want to train for rare diseases, right? It's not like general medical terms, not general medical symptoms. We want to connect dots that nobody has connected before. But we need that specific data to come in, and we need to get it from all over the world probably because we are looking for rare diseases, right? So there might be only a few cases in every city, in every country. So that's step two. We have the data. Then we do something that looks like training. We call it fine-tuning, right? We take a model and we teach it some new tricks. And in this case, that's good because we only want to teach it a few medical terms, a few specific things that in our field are important. We don't want to train it from scratch. And then at some point, we want to put what we have learned into production. And this is an important thing. So these projects, they don't end with the training of something. We want to put it in production, we want to use it for annotating maybe new nodes that get uploaded, or we want to bridge a gap that is created when we get data to train on, and it's health data, then most likely it's non-personalized data, it's anonymized data, because nobody wants to teach a model something about Mr. Smith having cancer. But when I want to use the model, I might want to use personalized data because I want to figure out if Mr. Smith has cancer from his health records. So bridging that gap is the difference between training something and putting it into production. So that's the high level of my project, right? That's what we want to implement. And Maria is now going to explain on what are the steps in between that I have to take from the data perspective as a researcher to making that happen.
So now we have this example. No? We have our research that has come to us. Imagine we are the system administrator, and they want to put this into action. They want to take some model, they need to collect the data, and of course that's the first step. They're going to need to collect data to fine-tune that model. And of course on that collection of data, it's going to come from multiple sources, and it's going to be in multiple formats. So, of course, this is not consistent, so we're going to need, in such an example, collect data from health, electronic records that might be on databases. We might have just raw tests that contain doctor notes. We might have semi-structured data, all coming from different sources. And when they need to collect that data, one of the challenges that is going to first start the project is how they can move the data. So if we are serving them with a file system, that could be probably the traditional choice, we're gonna need to provide access to those users that needs to move the data around. So here when we are dealing with files, we have already the challenge. So first, how savvy are those users? Because maybe some users are able to move, if we provide credentials and we provide access, they might be able to use tools like SCP or rsync, but other users for sure, they won't be able to do that. And so we might need to provide external services on top of that, so they can really move that data. That is gonna come in from different institutions. Such a project might need collaboration with hospitals, makes sense, to collect that data. Then, if we take an approach where we place object storage for them to move the data, that might simplify the work in our side. Imagine we are the system administrator. We can just create a bucket and provide URLs, and then they can move the data there. It's going to simplify the user management side of things. And here we are only about collecting the data. They are not putting that data together, that then they need to work on top on it. Of course, there is a full process of curate that data, not the scope of this presentation to go about the details, but a very important part, and it was just mentioned on the previous presentation, is about work that data, tag that data, and here is what we can call as well building the deep metadata, that we can call as well semantic metadata. We are not talking about file attributes or dates when the file was modified. We are talking about the real semantic that's gonna provide the meaning for the data for the model to be applied. Any AI project is gonna need an ontology. It's gonna need that formal definition of the knowledge on the specific domain. And based on that ontology, the researchers, they're gonna need to build that metadata. And this is a process that is often manual and distributed that starts with name entity recognition. Name entity recognition meaning needs to recognize text, recognize patterns, and then which entity relates to in that ontology. Here is not the same if we are talking on any other domain, if we are on the medical example. Here it's going to need to be able to recognize if in a medical note 50 milligrams appear. This is, in this case, we are talking about a dosage of a medicine, for example, or what are the different type of medication of maybe if a term like anxiety, the model will need to understand this is a condition. So that kind of entity recognition is part of that path. Once we have those entities recognized, we need to build the relations. So they need to be able to relate entities. And here is, as an example, could be if find the node that lisinopril was discontinued. Lisinopril is entity A, and this is a medication, or this is the chemical composition, and might be not able to what is the relationship with that cause, that what is not compatible with, for example. On that building node of this deep metadata, then we will have attribute assertion. When we are recognizing those terms and the relationship as well, the attributes has to be related properly. Like if we find in a test, as an example, that the patient denies to have chest pain, so it's not the same that the patient has symptoms of chest pain. So all that kind of semantic has to be collected. And of course, part of the big metadata has to be on that building, the content has to be normalized. So of course, doctors, first of all, we know they have a different way of written. They're going to use short terms. They will use their slang, so proper for the field, and they might use just some very specific terms. So all this metadata, as you can see, we are talking about recognized entities, relationships, attributes, and results on a complex metadata. We are not just talking about a few attributes that relate with every node that we have in our system. So when we need to embed and associate that metadata to the data we have, how we can save that depending on the solution we have at hand. What if we are providing the research with a file system, then as a researcher you say, I have a file system. Now I have to save all that needed metadata. Of course, this has been approaches that has been taken in the past and that has been used. But for example, that might be used to classify items using a path in the file structure. That might sound sensible, but imagine that just someone doing a move on the directory path is gonna remove all the relationship that they were assumed on that structure. It might create JSON files to save those attributes, but that implies some issues because when we need to query the data, this is good if we are doing just testing, if we are talking about a smaller scale experimentation, but when we want to take this to production, when we are dealing with millions of records, that's going to be not possible to handle at file. It's going to be very slow to query those values on JSON files for all nodes. We can take the object. Now, what if we serve with objects? Objects, first, they offer tags. We can tag data using S3 tags, and they become part of the object. Object as well, they offer versioning, something that with files is very tricky to handle. Versions with files, if we use file names, of course you have to be very consistent, anybody can break it at any moment. So objects with a flat bucket structure might help with some of the data management piece, but still they don't solve the query issue. If we really need to have all this metadata, it's not even effective when we sub it on the metadata to query them later. We're going to be again on the same trap. And this is where really our databases, what they will be the better fit for metadata. That we have graph databases, vector databases, and databases are optimal for queries. So that with the database approach, the metadata associated to those files, to those nodes, they will be easier to link to the object. So here we see a researcher, if all we can offer is just a file system because we think this is the capacity, it's the performance, is all they need, we are imposing very hard limitations on them when it comes to how they are going to be able to handle and to put those, that data on top of that.
And is that on? Yeah. Well, once we have the data and we have selected the data, the easy part comes, right? That's what I'm here for. The easy part is the training. From a data perspective, training is not in any way interesting, right? As we heard in the talk before, 60 to 80% of the work is done before the training or after the training. The training accesses data with high performance, but in many, many training cases, performance is not the main issue. So we start training, we can do that on a file system, we can do that on an object storage. We see a bit of a trend in the market that stacks move into the object direction just because they come from cloud environments, and in the cloud the object is the normal consumption model. If you want to build an infrastructure that allows people to move their stack from the cloud to on-prem, you need to offer an object interface. But from the training perspective, the data consumption is relatively easy. You read stuff, you stage it maybe to a local device, and then you kick off your compute. From the compute perspective, training is the most interesting. We understand that.
Yeah. So we have our research that has been collected the data, that has dealt the data, that has trained the model, but now they need to put the model to work. And really I like it, what Eric mentioned earlier this morning about you need, in such a project that we're going to see more and more, they need a plan. This is not going to be just for the fun to create a new model. It's going to be what's the plan for that? What is going to be the use case and how you put it on production? And here is where we talk about how you put this model to work. We have, of course, simplified this process to the minimum. This is way more complex, what we show here. But when we are putting a model to work, we are creating a pipeline. No, and there's a series of phases that are going to take place. We have our model, and now we can have new nodes that doctors gather from patients that are going to be uploaded somehow, either processed on their maybe on computer, or it's going to be uploaded to a central location. And once the node gets loaded, then it's going to be that phase where we're going to create all the deep metadata. That data is going to be tagged, and then we're going to chunk the data. So the chunking process usually is used to, of course, paying attention to the semantic side of things, and as well, depending sometimes as well to fit on the memory of the model, then we will be chunking the data to be processed. And on that, they will be creating embeddings. So we're going to save that nodes that we have processed with the model, we save it as well on a vector, on vectors. When we have to implement such a pipeline, if we have a file system, how we are going to do the processing? Because imagine that we are going to have nodes that are being processed, are going to be unloaded. We could have, as a traditional process, just a batch job that is going to monitoring for new nodes, and then it's going to, every time that detects there is new nodes, then it's going to trigger. No, we are from HPC background, we are batch processing is very known to us. Or we could not be constantly polling that. Of course, once we monitor the nodes, they're going to let the job running, and then we will have, now again, where I'm going to store the vectors that are the results of process those nodes with the model. If I only have a file system, do I save them on files? So we are back to the problem. We won't be able to query them in an efficient manner later on. There are options where it's possible to run a vector database with a file or a block backend, but these are very complex. No? And of course, the user itself might not be the one putting that into, in configuring that. So imagine he's a researcher, he's just focused on his research, he's not focused on how to run a vector DB on top of a file system, always down to the system administrator to set such a thing. If we are using objects, we could, again, how we are going to monitoring those nodes that are being uploaded. We can be scanning the buckets, but well, if we know buckets, they can have bucket notification. But still buckets notification, while we can use it to trigger events, it's not going to help us to orchestrate the entire pipeline. And at the when it comes to what do we do with our vectors, objects that not put us in a better position. We are again, we will be, if we save vectors on objects, the queries, they don't really scale. Run vector database with a S3 backend is possible, but it's going to as well hit some limits when we come to scalability. So that is the reason where we see that advanced data services are really crucial to serve these initiatives. And this is where we really know those such projects, from the infrastructure point of view, is critical to consider that those services should be available for them for simplify the process and being able to optimize how they put them to production. And between those services, we have to provide vector database as a service. So it's a really scalable, supported vector database where they can save it and is part of the services we offer to them. That is going to allow for the real-time insights, and it's going to be consistent and available for the service. So being part of the services we offer to the research to be available on building such a pipeline. And when we are talking about the build of a pipeline, event broker will be one of the additional services will be crucial to offer to them, because that is going to allow the research to build pipelines where they can very easily respond to events that could be internal, that could be externals, and then orchestrate those pipelines. So those researchers, they will need much more than just file and objects. These services become part of the full package they really need to accomplish such a project. And when we are putting such a project on production, this is not just a one way of direction. Usually, we are going to need to do a continuous improvement of the model. We are a part of processing nodes as they come. Probably we want to go along the way to make sure that the model is going to be revisited, that it's going to be improved. Like it's going to be including expert validation. Like could be the possibility to have outputs of the model, nodes that has been processed together with the output, that they can be ingested into a dashboard where expert can go and validate them. For example, not necessarily all of them, but maybe the ones that are rated with a lower confidence. And on part of that evaluation, in this pipeline that we are building that allow us to manage not only events not coming from external but internal, will be possible to do all that expert validation. Once we have accumulated enough new input, might trigger another fine-tuned job to generate a new version of the model. And once we have a new version of the model, that is going to be put into the model registry, because of course these days we know we are talking with AI, agentic AI, and this is going to be a cycle where we need to improve the model and in an iterative way, and it's important to be able to track those and be, the data lineage and the model, the outputs, which version of the model has been generated, all of that will be as well relevant to be captured in the system itself. Such a workflow will be easier for researchers when they have all those services available for them.
So, a very brief insight in how it might look like from the user perspective. AI adds multiple dimensions to the data problem. It's not just storing data, we also have to store the context, the meaning of the data, and have to make it accessible. And we have to make it accessible in multiple ways, because that's how the stack expects it, or how the users expect it, and how it makes it easy for them to work with. So one important message is don't push the complexity up the stack. In HPC, we have used to that. In HPC, that was always the thing. You get a fast file system and the rest is up to the user. So invent your data formats, invent your services, do whatever you need. In AI, this puts a serious capability gap in. So some of the workloads might not even run if you don't provide these kind of services. So moving into that direction allows the users to do their work. And we saw in the previous talk, the 60 to 80% of the work gets done outside of the training. It's still forgotten. It's still like people expect that this work happens outside of their infrastructure, but it might just prevent people from coming to your infrastructure. And then one thing we did not explicitly address, but it implicitly is there, if you start building silos, like for the functions that we just talked about, then you will start moving data back and forth with all the bad stuff that comes with it. It's effort, it's data management challenges, you create copies, you create versions, you have to merge them. So create infrastructure that is not moving data, that is basically minimizing data movement, because looking at the metrics we have seen before, this is all like production grade utilization metrics. In research and in science, this is typically not what blocks people. This is not what costs money. What costs money is, how do I get the data where I need it to be, and how do I create the stack that I actually want to run? This is your performance metrics. If the output of the GPU is X or Y is interesting, but it's not blocking the project from being a success or happening at all. And while all of this was not at all vendor specific, we at least have to put in one vendor slide, of course, because all the data services we talk about, they ended up in the vast data platform. This is what our product basically offers, because this is what users have told us that they need this to get their job done. So we offer file, block, object, vector database, databases, all these kinds of things in a single unified platform that you can deploy. But there's other products out there that have similar things, so evaluate them, pick the best thing, but please don't build platforms or infrastructure that only offers file, because these days should really be over, because users can't put their data where they need it to be in the format they want it to be.